Good morning, my friends, my fellow members, organizers, Crypto Red, for having proposed me to take over from you and for having selected my work, my paper, my presentation. Thank you all guys for being with me today. My today's presentation is doing research about web application firewalls. I will show you a summary of some of the main aspects of my doctorate thesis I'm currently doing with the Superior Council of Scientific Investigations. On my today's agenda, I will present to you the three WAPs. Yesterday we talked about attacks, cyber defense. Today I will focus on the defensive area of firewalls, which does not prevent me from knowing how to attack, how to be a good attacker. Later on, I will talk about how we can acquire and take the data to evaluate these systems and then to value and assess the results, and then finally make a comparison between systems. Typically speaking, within the area of detection of intrusions, we can distinguish two approaches. Very first approach based upon signature, based upon the fitting of very known patterns, unlike the one based upon anomalies, which defines the normal behavior of the application, and those actions deviated from these behaviors are the ones considered anomalous. The advantage of this approach allows us to detect new attacks not seen before. Therefore, this approach has been chosen for this doctoral thesis. In fact, is my doctorate. I try to make it as practical as possible to all of you guys. I will first show you the three graphs designed for this purpose. I would like to make a gap to tell you that are the WAP detection engines, the part of WAP, based upon draw the conclusion and classify the request as normal or as anomalous, as normal as proper. I've divided the two systems in the stochastic approach. Stochastics use statistical techniques, and the one whose detection engine is based upon Markov chains. The third system follows a machine learning, using for this purpose decision trees to make the right classification. On this figure you can see the WAF and the data set containing the requests who are going to feed the system. For us to design these systems, we count on the very first stage of reprocessing, in which the petitioner request entry is parsed and divided in different components, and then the characteristics are extracted that help us to detect the attack. Let's move on to the processing. Firstly, the training phase of training the system takes place. The system is trained when the system learns the normal behavior of the application, which is legitimate. In the design I made, the knowledge extracted from normal requests, in this case, is stored in a file called the normal behavior description file. Once the system is trained properly, is operational, is put in action, and in this very case we'll be receiving normal requests and abnormal requests, which have to be classified adequately. For this purpose, the system will proceed as follows. The system will compare the characteristics extracted from the incoming request based upon the stored knowledge in the file. As I said before, for me to speed up and make the thing more practical, I brought you this demo for you all guys to watch it in detail, in depth. Firstly, we have the web application to be protected. In this very case, it's an online shop where you can buy very typical Spanish products. If you like the Andalusian ham, the Habu ham, where users can sign up for it by inserting their personal data. In this way, they can ask the orders. Now let's protect the application with the WAF. With the statistical WAF, very firstly, we'll conduct the training phase of the system, in which we are going to know and find out the normal behavior of this application. I boot up and start the system. For me to speed up the whole thing, I will create an offline training with a set of 1,000 requests I previously prepared. If I don't skip it, as you can see now on screen, normal behavior description file detection model, it only took 2 seconds for the system to analyze the whole thing. In this way, the normal behavior description file is generated where all the characteristics of this request had been stored, sent to the system. And now you can see on screen this file containing the resources, the legitimate resources. It starts up again. The file, as I said before, the file contains the registries where you can access the arguments, characterize, and we code with the detection models. Okie dokie. In the normal behavior description files, detection models are contained which help us to detect the attacks. In concrete, specifically, two models of detection have been selected. The first one is based upon the length model of the request and the different parts of the request. This is a very important variable for us to detect overflow attacks. Second model is based upon the distribution of characters. As the warfare art says to us, we need to know our enemy to combat him. Regarding the fact that several characters can be indices of attacks, I divided the attacks depending on their nature, distinguishing the number of digits, letters, and non-alphanumeric set. This is used by the statistical system to define a series of intervals delimited by a maximum and a minimum value, among which values are considered to be normal, and all which is outside this interval is anomalous. In the case of the second system Markovian detection model, the design is similar to the previous system I mentioned, with the particularity that the segmentation is done with Markovian chains are mathematical models characterized by certain statuses and states and the transitions in between. I left a reference for you guys to get deeper within the subject matter. Once the system is trained, let's move on to the test detection process stage where the detection is conducted. In this process, the request is analyzed, the incoming request is analyzed, which has to be classified as normal or anomalous based upon the knowledge stored in the file. In this process, we start analyzing every part of this request. Very firstly, we analyze the HTTP. In case this is correct, we can analyze the rest of the resource. When very firstly we detect that one of the part of the request is not correct, the whole request is totally rejected. This allows us to save money and save resources as well. Is one of the main characteristics of design which distinguish this design from other state-of-the-art designs. Then we move on to the next thing, which is to check the headlines or headliners, the arguments. Headers and arguments are taken. Once all the steps are correct, the request is served to the server. In this way, or otherwise it would be blocked, and this would prevent us to have an attack on us. During this process and steps, it's also carried out the detection of the process detection evaluation. In the case of the statistical system, we will evaluate if the characteristics extracted are within or outside the intervals. So this could be a simple system on the condition that systems are efficient enough to cope with the problems. In the case of the Markovian system, for us to calculate all this, we calculate the probability that the generated chain can be created by the Markov's model previously learned in the training phase. In the case that this overcomes certain threshold, the request is considered to be normal. Okay. So let's move on to the next demo time.
Para ver ahora el sistema operando en la fase de test.
Let's see now the system operating in the test phase. I will do it online. So I redirect the traffic to the port through which I was listening to the WAP. During this stage, while the requests are normal, everything is okay, the request is uploaded, but what happens if you try to attack? The WAP would detect it, and WAP tells us the request is rejected, so it does not reach the WAP. In between, on the behind, WAPs is analyzing all the requests, and it says arguments are not valid. We continue to attack with the cross scripting, and request rejected. WAP is blocking it. So we don't only analyze arguments, but we also analyze server resources. When we try to access the etc password, the WAP would detect it and it would set us this is not an admissible resource. We can also use certain tools such as W3AF, which is one of the tools used for the previous set of data before, which exploit the vulnerability with security injection, QLMAP, and once again we can see that when we test this XQL injection, WAPs by analyzing digits, letters, and parentheses will tell us, okay, no, there's no way, Jose, you won't go in, and then we'll protect our server.
Esta, ¿verdad? Bien, pues voy a pasar ahora a comentar.
Let's move on to comment the third system based upon a machine learning approach. In this very case, during the pre-processing stage, a new method is proposed to extract characteristics. Normally, we have always used the expert knowledge and the automatic techniques such as enigrammas to extract characteristics in a separate way. But in my thesis, I tried to combine both techniques. I will prove you to all of you. I will show you later on. With the resource of all of this. This combination implies that the number of characteristics grows and new stages include us to selecting more characteristics, which allows us to eliminate the redundant characteristics and take on only the characteristics which really matters and gives us the valuable information to detect attacks. For this purpose, we have been used the generic measure of selection of characteristics proposed by Nguyen. Even though he was successful with another type of traffic, it wouldn't be before applied to this kind of traffic. Regarding the training trees, so we are using trees to classify. We use 4 relevant trees within this field, which were not applied before for analyzing web traffic. Okie dokie, once we have the systems, we can wonder what way can we evaluate the systems? How can we know if these systems are correctly detecting the attacks? What way can we obtain traffic to evaluate the systems? For this purpose, is a label set of data is needed, but data acquisition of this is not this easy. The biggest problem we have to confront, the most significant challenge that is the lack of appropriate public data sets for assessing anomaly detection systems, which triggers that many investigators, researchers have to create their own data sets, and due to privacy reasons, they cannot publish this data, which impedes systems to be comparing between. During my research, I have listed all the characteristics which are desirable for a data set to evaluate correctly the systems such as WAPs. Among them, I mentioned that it's desirable that this data set has to be public to allow us to compare different systems, and by containing traffic HTTP, which is to be analyzed here, is a must, is indispensable that the traffic has to be labeled for us to evaluate the system properly. At least it has to differentiate between the normal and anomalous classes. You know that the web attacks are showing us new vulnerabilities, so these modern attacks has to be included in the dataset for us to know, to evaluate the WAP's behavior before them, and to create datasets which has been criticized for not containing updated attacks. It's also very advisable that the data have known to be anonymized for us to get a more real picture of what's going on here. On this table, I have selected the datasets used more usually within this field, more extent one. As you can see on screen, none of them meets the desired characteristics. What can we do for this situation? What can we do, guys? In my thesis, I propose the creation of our own data sets. In particular, I created the Superior Council of Investigation in Spain's data sets and Torpida data sets, which really meet all desirable requirements for them to evaluate properly these systems. The CIC dataset contains 36,000 normal requests and 25,000 anomalous requests, and it also contains modern web attacks. It's totally accessible, public, and you can download it from this link on screen. Besides, Torpida datasets distinguishes between normal requests, anomalous requests, and attacks. As you can see on the screen, Torpida datasets includes a full range of modern web attacks, and requests are labeled depending on the type of attack. In the very same way, you can go on this link on the web and download it as a set, and you can double-check all the framework documentation online. Okie dokie, once we got the systems and the data with whom we are going to fit them, let's proceed to the scientific experiments. The results I'm going to show you are based upon the SIC dataset, and I've measured them depending on the attack detection rate and false positive rate. In this way, the statistical data set reached 99.4 detection rate, markup chain 98.1, and machine learning 95.1. I'd like to comment on the fact that of the new novelties given by the systems. As I mentioned before, a new method is proposed as to extracting new characteristics which combines the expert knowledge and the enneagrams in such a way that you can see that the detection rate results by combining all these things improves the results of the two techniques done separately before. Besides, it's the very first time which is successfully applied the measure GFS measure. By applying this GFS measure, you can see that the number of characteristics is around 63 and 91% of characteristics, and obtaining characteristics, which reduces the time and reduces the resources in analyzing and processing every one of these requests. As you can see on screen, my thesis tried to optimize different aspects of these ops. On the other side, I conducted a study as to knowing how the training requests impact the results of the systems by seeing that it's possible for us to optimize the training stage by reducing the number of requests used to train the system. In the case of the CSIC database composed of 61,000 requests, I noticed that in the statistical system with a quarter of these requests, we can use adequate results. It is to be mentioned that other systems, state-of-the-art systems, use between 2 to 10 more times requests. This reduction is very relevant because beside facilitating the traffic for training, allows us to save money and resources during processing. Okie dokie. By comparing different systems, I can wonder which is the best possible system, the best one among all of them, which is the state-of-the-art system. As usual, it depends on the environment we are moving in. As you can see on screen, in yellow on this table, in the case that the detection results are more important, is the statistical system would be recommendable. But if the system speed is very important. The machine learning allows us to get a better processing thing. In those environments where it's difficult, the projection of the labeled traffic, we can see the statistical system can get us good results by using fewer numbers of training requests. We are running out of time. If you want to go into deeper and deeper knowledge about this investigation, my research, my thesis, you can check out these publications online on these links. Lastly, to wrap up my presentation, I'd like to leave you some reflections about the defensive behavior of the WAFs, the web application firewalls. That's why I brought you a proverb from a Prussian military people who studied the modern science, who says, "What is the defense in conception? The warding off a blow. And what is then its characteristic sign? The state of expectancy or of waiting for this blow." This is it. I leave you this reflection, you all guys, to have a thought at it. Thank you very much for your attention.
Preguntas.
Should you have any questions, please raise your hands.
Sí, vale.
A question for you, Carmen. Congratulations for your marvelous study. Logically, WAPs. We usually check the effectivity ratio to minimize false positives and the rendition, but in the non-academical world, you didn't analyze this process. The thing is that the web application changed so quickly that this training we have to do, it has to be a constant training. What training would be more easier for us in the everyday training based upon the number of petitions and requests? Sometimes it takes you longer to analyze this quarter of statistical things. So, other question, torpedo, what does it mean? Torpedo, I would start with torpedo. Torpedo is a funny thing, man. in the very beginnings, I like you to ask me because this reminds me of my very first fellow colleague Alex in the origins of these crazy things I did for you all guys. My name is Torrano, and his surname is Torrano Perez. We murdered Torrano and Perez, Torpedo. So the very first question you asked me, of course, these kind of systems, one of its drawbacks is that when you change the websites and the pages, you need to train or retrain again. So now, what are we doing? We are focused on dynamic systems and adaptive systems. Depending on the number of failures, depending on their failures, they learned. They continue learning. It's a continuous learning. The training never stops. So these systems learn from their failures, and there are systems which adapt to the traffic volume, their environment. So this is totally studied, and we are we're getting deeper in their knowledge. Among the three systems you mentioned, which would be the desirable and recommendable, we should implement in their current state the adaptive state, but it would be easier in every three of them. I don't know. Perhaps a statistical system being this easy and very effective, the results I show you applied to the SESIG data set. If we would have taken another data set, the results could have been difficult. Conclusions are not always same. We cannot prioritize by saying this is the better, this is the worst. We need to pay attention to the data set analyzed. 3 years ago, we discussed on the routed email list why there is no total virus service orientated to WAP. You can create a WAP service where our guys can test applications with predictable data set, and when the process, Raul told me before, it's very complicated, but this is the right way for you to, in your research. It would be very interesting, and we should give it a thought, of course. I do think it's a very good idea. There are many companies here that can give you money for it. Oh, companies, I'm on them. Like I said, it's necessary for all of us to obtain traffic. One of the drawbacks, a very tedious drawback, is the fact we need the normal traffic of the application. The moment you get the application traffic to be protected, it's easy. It's very easy. You only have to send it to the WAP period and run it. But if you first need this normal traffic, there may be different ways to cope with this. If different users are around it, or messing around the application like spiders, there are many other ways. Raul is over here. The truth is, it's a very interesting thing. I'm keen to giving a second thought to all of it and to establish a collaboration with the WASP people. Fabio is around us. Fabio told me I would be here. Fabio can send you over what they're seeing in the set of application. Then Google will hire you and will pay you 20 million euros for your service, Carmen. Carmen, can you hear me? I had two questions. Raul stole one of my questions, so I will speed it up. When you talk about automatic learning things, we are focused always on the good things, but we don't see the false positive, the false negative of the automatic learning. Did you check it? Can you comment on it? And how can you deceive these methods, since you have studied from inside? When you see the false positive, there are certain cases that screw up everything. The fact is that when I show you these results, the comparative results, as you said, the machine learning system regarding detection result, is true that it gets lower results and the rate of false positives is higher. So, but the principal benefit that gives us to the system is very quick. Is fucking quick. velocity, the speed is so quick, so it depends on the environment you're in. Certainly, regarding false positive, I would recommend the other one. Anyway, you should realize that these systems are linked together, are linked with CM system, which eliminate false positive and they correlate in between. Nevertheless, there was another part in your question I forgot. Sorry, can you remind me of it? Please get it. The interpreter cannot hear what the speaker is saying because he's not using them. How can you eliminate these statistical? How can you deceive the system? We have a paper recently published based upon the evasion of walls based upon automatic learning. There you go. That's my question. There are some very interesting ideas on this paper. I'll tell you later. Thank you. Hello. I would like to ask you about the learning process. I understand that training is based upon dataset, but how can you distinguish when an attack is effectively an attack and not being included in the dataset? From then on, how can you learn that this is in fact an attack? You first have to eat this attack, and then you have to learn it. How is it? What's it like, this process of learning? Like I said, it's important that the data set have to be labeled. So I start from the requests with the label. I know if they are normal or anomalous, and this allows me to then know that once the system is analyzed, it allows me to say if this was a normal request. What must says to me, okay, it's a right request, but what must says to me, okay, it's wrongful, so there was a failure, or vice versa. In the case of statistical systems, they are only trained with normal requests, because, like I said, it's an anomalies-based approach. This is the normal thing. This is what the application is permitting you to do. Everything outside this is considered to be anomalous. Therefore, any attack, that's why it's so effective detecting attacks, especially new attacks never seen before. Okay? I think I'm asking your question, am I right? It's necessary for us to label the requests, for us to distinguish what's going on here. With the decision trees, I'm giving you a set of requests. These are normals, and the other one, these are the attacks. It elaborates the trees with different branches, and then the lips of these branches in the trees gives me the classification of anomalous or normal. You commented before. Hello, you commented before that you worked on detection engines. Have you implemented this part of what the statistical algorithm is doing, the Markov chains? Have you developed these algorithms? Are these algorithms published? Have you used a paid tool or a free paid tool that gives us these algorithms? But in general, free tools use patterns or templates. They don't use advanced algorithms as the ones you exposed to us. Have you implemented these algorithms? Are these algorithms available for all of us? Are you going to publish these algorithms? All I showed you before with demos had been developed for us. It's our own development. We have developed the WAP, the detection engine, and what is being received, the request to be sent to the server, everything is developed by us. So statistical algorithms and Markov algorithms have been implemented by us, and they are implemented into the system. Nonetheless, in the case of machine learning, for avoiding reinventing the wheel, we use the implementation of Weka, which is a public tool that can be used by all of you guys, which has many algorithms of machine learning and artificial intelligence, and you can find many other algorithms. I ask you and I advise you to play around this tool. And regarding the publication of the code, it's something pending for me. I have to talk with somebody else to wrap up the whole thing. But I would like you to put available for revise this code.
Hola, buenos días.
Good morning. Congratulations for your marvelous presentation and work.
Quería hacerte una pregunta.
A question for you, Carmen. For instance, a request, a request where you use some kind of codification 64 based. In this case, the statistical system works properly. We bore this in mind, we took it into consideration. The petitions requests are decoded before processing and before everything. We have to check and test different types of codification, and of course, they are decodified before analyzing. If they are normal, they are sent to the server and they are decoded again before sending. We have to check it all. Thank you very much, my friends, my fellow partners. Thank you.